Okay, so you have a circle. It tells you the area, this little shaded part tells you the area is 7.8 centimeters squared. It does not give you a radius. Okay, it doesn't give you an arc length either. You don't know how long this is. So we could find out both of those things. In fact, I think the question is find the radius of the circle. So once you think about this, x over 360 times the area of the circle, the area of the whole circle, okay, equals the sector area. So SA, I'm just going to abbreviate sector area. This is my little formula, right? And we know that 82 is the degrees over 360. And then we have the area of the circle. Yes, we don't know the area of the circle, but I do know that the sector area is 7.8. It gave me that. So how can I get rid of that fraction? You want to get a fraction to go away, what do you do? Yep, so 360 over 82 on this side, 360 over 82 on that side. And then these go away. I think we talked about this one yesterday in class. So you end up with the area of the circle. This is the whole area, by the way. And you could put all of that in your calculator and get a number. Yeah? So all of this in your calculator and get a number. Now, what do you know about area of a circle? What makes area of a circle? What formula? Area of a circle.
Pi r squared.
Okay. So if your number here is equal to pi r squared, and I'm looking for radius, what do you have to get rid of? Okay, so you divide by pi. Very nice.
And then you get the square root of 38.
Okay, so you find the area of the circle. You divide by pi to give you r squared. And then you take whatever number that is, so whatever number this is, and you take the square root of it, and that will give you your radius. Once you have your radius, can you then find the length of that arc? Yeah. And what formula would that be? What's arc length formula? Is it still 1x over 360 pi r squared? Pi r squared is area. If I'm finding length, I'm finding a piece of that circumference. 2 pi r. So this would be number 6, the second part of the box. 2 pi r. So you take this r and you plug it in right there. And you can actually type all of that in your calculator because that number 6 is just like a warm-up question. You just did it. Okay? So I'm hoping that by reminding you what you should have done yesterday on number 5, that you now are done with number 5. Okay? Let's talk about this next one over here. I really like this question. Okay? And here's my little cookie cake over here. And it says that the cookie cake is cut into 6 equal pieces. Sorry, but I'm eating all of them. Okay, they're all mine. Cookie cake, 6 equal pieces. And it says that the arc length of one of the slices is 4.2. So I just put a little arc in orange, and I know that that's 4.2. If I wanted to go all the way around the circle, what can I do with 4.2? Times by what? 6. Why 6? Because there's 6 equal pieces, right? And if you do that, you're actually getting the circumference. So the circumference would be 6 times your arc length. You could find the circumference very easily, right? I'm not going to do it for you, but you could come up with that. And then if you come up with the circumference, what does it ask you for? It says diameter, right? So what would you divide? So this becomes some answer that you come up with. What would you do with that answer to get the diameter? What is your circumference formula, guys? You would. If circumference is pi times diameter, and you know that number, then you just divide by pi. Okay? And you get your diameter. Once you know your diameter, what else could you get? Good. So you get your diameter. Hopefully you have it by now because I'm basically walking you through the thinking. Then how do you get your radius if you know the diameter? Okay, so then you get your radius. So question 7 wanted the diameter. All right, you take your arc, multiply by 6, and then you divide it by pi, and you got your diameter. Then you got your radius. Now that you have your radius, can you answer number 8? So number 8 says, what is the area of one cookie slice? Well, if I just want one slice and I have this whole circle here, what do you need to get area? What is required to get area of a circle? The radius. So can you get the area of the circle, the whole thing? Yeah? So this is the whole thing. And if you know the area of the whole thing, what would be the easiest way to get the slice? Divide by 6. Okay? Now, could you also, how many degrees are in a circle? How many degrees are in a circle? How many degrees is one slice? 60, right? 360 degrees divided by 6 gives you a 60 degree. So you could, right? So the whole circle, and then you said divided by 6, and that would give you your slice. So this, to me, is working very efficiently. The other option, after you get your radius, would be to use your sector area formula. So 60 over 360 equals pi r squared, or times pi r squared. You should get the same answer. Okay? So either way would be fine. Sometimes it just takes a hot minute to sit down and think about, what is it really asking me for and what do I know? Because I don't have to go here if going here is easier for me. Does that make sense? Yeah. Okay. Then, lighthouse problem. Anybody ever seen a lighthouse? Yeah. Where does it shine its light? Into the water. So do lighthouses, do the lights go all the way around? No. Every once in a while I find one where they have gone all the way around, but how do they usually go? So, yeah, they kind of go back and forth like this. Okay? Now, so you have this lighthouse, right? What else do you know about that lighthouse? What does it say on your paper? What does it say? It's visible for 18 miles. Ah, that light beam of 18 miles. Ah, there you go. There's your radius. Okay. And does it tell us anything else about the lighthouse? So the beam of light originates at the lighthouse and it comes out 18 miles. All right. What else does it tell you? It sweeps an arc of 460 degrees. Okay, that's actually that's a way bigger arc than what I just drew. Okay. It's almost 3/4 of the pie, right? Okay. Why would I want to know the area of that light beam? Why would I want to know the area that that light beam covers? Why is that important? Who cares, Miss Bailey? Why? Somebody cares. Who's going to care about where that area is?
So the boats.
The boats. Okay, the boats are going to care about that light beam. Okay, the people who make the lighthouses, they have to know the area that the light beam has to cover. If the light is too dim and only goes like 3 feet, do you think that's going to do anybody any good? No. So they have to make a light that is powerful enough, and then they have to have the right kind of mechanics and mirrors and all that in the lighthouse that will shine that light way out here, 18 miles, and then sweep back and forth all that area. What are they trying to avoid? What would they crash on? The rocks. Other ships, the rocks, like all this stuff under the water that you can't see, especially at night, right? So this is actually an extremely applicable piece of math that normally most people don't really ever think about, right? But it's really important. Okay, so what would you use to get that area? If you're the one designing this lighthouse and putting this together, and you need to make sure that your ships are safe, you've got to figure out how much area that light beam has to cover. So what would you use? What formula would you use? What formula? Okay, what's the area sector formula? It's on your sheet, guys. Good. Times what? Pi r squared. Do we know the measure of the angle? Do we know the radius? So would it be easy for us to calculate the area that that light beam covers? Yeah. So you could be doing that. If your light beam doesn't cover enough area, you got to go back to the drawing board. Okay. Does that make sense? I love this problem. I could go on all day about all the things that are involved in this question and the places that this question could lead you to. We don't have that kind of time today. Okay, last one. Now I want you to think, I know everybody has their own preferences for pizza places, but let's say that you're having a party and you're on a limited budget, so you go to Papa Murphy's, right? And you get 2 pizzas, and you're staring at 2 pizzas, and you know for a fact that, okay, you've got, your 16-inch pizza. You do realize that when you hear the size of a pizza, they're talking about diameter. Does everybody know that? Okay. Little known fact. Then you have your 10-inch pizza. And what this is asking is, which has more pizza? Just half of the 16-inch pizza? So maybe you don't have a big party, but you want leftovers, right? You want leftovers after your party because you can take them to school the next day, or you work or whatever. Or you want to share them with someone in particular, right? Who's not going to be at the party. So which would give you more pizza and have stuff left over, right? So half of this or all of that. So how would we answer that question? What would we need to find out? The area of both. How do you find area of a whole circle? Okay, so pi r squared. Now, are you going to use a 10? What are you going to use? Why? Yeah, so you need the radius, not the diameter. So we're going to have the whole pizza over here. Okay, and then we're going to have to do the same thing over here. What's the radius for the larger pizza? 8. Okay, so let's figure out if there's a way to put that in the calculator all at one time. You told me that the whole pizza is pi r squared. That's true, but now I just want half. What do you do? If I only want half the pizza, what do I do? If I only want half of the pizza, what do I do?
Divide it with 10.
Which means
Divide by 10.
you divide by, if you divide by 1/2, you're actually multiplying by 2. So you want to divide by 2. I know you meant cut it in half. Okay. Can you stick all of that in the calculator at one time?
Yes.
Yeah. So just by taking a moment to think about what it is that we're doing and where we need to end up, you can actually make your questions a lot more efficient when you work them. Okay. So what I need you to do now is I need you to wrap up your question, and I need you to put your name on your paper, and I'm going to have you turn it in because we're going to move on to the next thing, which is graphing circles. Okay, so wrap your question up, put your name on it, and let's get it turned in. All right, so now we're going to move on to the actual thing of the day, graphing circles. I need you to have a compass, and I need you to have something to write with. Personally, some kind of color would be helpful, but you don't need a color if you don't want a color. Okay, here we go. Circles. I want you, we're going to write some stuff at the top, and then we're going to go work through some of these things. And we're just going to work until I'm done with my few examples, and then you're going to finish it out for the rest of the class period. Okay, so the first thing is I want you to write down x squared plus y squared equals r squared. Now, what number is in front of the x and the y?
1.
1. Okay, so I'm writing this because I just want you to just kind of remind you that when you have a x squared and y squared, you have 1 in front of it. That is good because then you know that you have your circle equation, and the circle equation just does change a little bit. But when you have this situation right here, your center of your circle is at 0, 0. When you just see x squared, then that's a 0 for x. When you see y squared, it's a 0 for y. And then to get your radius, you have to take the square root of the number on the end. Okay, you actually have to calculate the square root. In other words, the number should get smaller, not bigger. Please don't square the number. It's already squared. You have to undo the square. This is your parent function for circles. They all start out living at home, just like you. So at home base, which is 0, 0, that's the center. And then your radius is however big it is. As long as our radius is 3 or bigger, we can use the circle or in the middle here of our compass to draw our actual circle so that they don't look like melty Easter eggs in the yard, the chocolate ones that kind of like bleh, get all mushy. Okay, we get nice, crisp, clean circles. Okay, over here, I want you to write this down. Are you ready? X minus h in parentheses, and then square that. And then y minus k, and then square that. And then you're still going to have r squared on the end. So that's an important number there. Okay, the h and the k are very important numbers. Okay. So we've just changed from this to this. This format tells you that your circle is no longer at the origin. It's moved around, okay? And so to get your center, you need to look at h and k. That'll tell you what your center is. Your radius is still the square root of r squared. Now, as far as h and k are concerned, right here, do you see how this says minus h and minus k? Okay, so if I do x minus a number, right, h is actually a positive. And if I do y minus a number, then k is actually a positive. So these, when you pull the numbers out of the parentheses, they are the opposite sign. If you see a plus sign in your parentheses, you would pull out a negative. So right here, H and K, opposite sign than equation. And it's really important that you remember that. Okay, the opposite sign than the equation. Okay, so I'm going to show you kind of how all that works. And you're going to see, as long as you remember opposite, you'll be good. Okay, so for these up here, you are given the center and you're given the radius. So we're going to write an equation. Okay, that's our first task, is to write an equation. So here's my center, and this is H, and then K, and then it says the radius is 1 unit. Well, what would 1 squared be? So if this is R, what would R squared be? What's 1 squared? 1 squared. 1. Very good. Yes, it's raining outside. Okay, everybody look at the window. It's raining. Okay, back to circles. So we have H and K. Do you see the 0 and the 5? So when H is a 0, remember up here, when H is a 0, we just write down the x squared or the y squared, whichever one we're working with. Bless you. And then you need a plus sign. There's always a plus sign right here. And then we have a K. The K is a 5, so I'm going to do y minus 5. Remember we said we had to subtract the K? Well, if K is 5, I do y minus 5. Everybody see that? So here in the center, it's a positive 5, but here in my equation, it says negative 5. All right, then I put a square. And then the R squared, this number that we got, we're going to just put that on the end. Okay, so x squared plus y minus 5 squared equals 1, which is R squared. Now, I need somebody to pick another one. Quickly, pick one. 4. 4. All right, this is H, and this is K. This is R. So R squared is what? What's 3 squared? 9. Very nice. Now that I know what all my pieces are, I write them in the equation. So x minus 2, because that's H, square it, plus sign. Y minus 2, H and K just happen to be the same number for this one. And then I'm not going to put equals 3, I'm going to put equals 9, because the number on the end is R squared. The radius is 3. If I square it, I get 9. All right. And I want you to notice that here is my center of 2, 2, but in my equation, they're both minus 2, minus 2. Everybody got that? Okay. The next, you're going to do the other 4 on your own. Let's go to the bottom section. First of all, I don't know why, but everybody thinks that's a negative 9 when it really is an equals 9. Okay. All right. There's no division signs. If they look like they're faded, they're plus signs. Okay. There are no division signs. Okay. Let's do the first one, and then you can pick one for me to do. This time, so we took the center and the radius and we made equations. Now we're going to take the equation and we're going to write the center and radius, and then we're going to graph it with our compass. So if I look at number 1, H is a 3, a positive 3. Y squared, there is no K with it, so K is a 0. This 9 is R squared. So what's the square root of 9? 3. Okay, so the 3 numbers that I need are 3 and 0 and 3. Those three numbers right there. The center, which is HK, your center is always H comma K. I'm going to write down 3 comma 0. The sign in the equation is minus, but here it's plus, so it's always opposite. And the radius is not 9, the radius is 3. Now that you know these two pieces of information, you can graph it. So we're going to go do that. 3 comma 0. I set my pencil at 0, 0, and I go over 3. I don't need to go up or down, so my center is right here. Then my radius. Here's what I like to do. I kind of make 4 spokes to a wheel, or you could think north, south, east, west, doesn't matter to me. Okay. I draw 4 radii, and the reason why I do that is because then I can take my compass. So grab your compass. As long as my radius is 3 or bigger, I can use my compass. It'll work. Put your center on the center of, put your compass center on the center of the circle. And then I want you to rotate that wheel that's inside, right? And you're going to find the closest one. It's kind of a toss-up between that one there and that one there. Find the closest one that goes to the end of your radius, and then use it to draw your circle. Okay. There's your circle. Nice and neat and clean and pretty. Okay. We're not going to freehand the circles unless they're just way too small for the compass. Now, I need somebody to pick one of the other ones that are here, and I'll work that one. Question 4 again. Okay. Looks like it's a 4 kind of day. So it says x minus 2. Well, that means that h is a positive 2. Y plus 4. That means k is a negative 4. My r squared is a 16, which means r, a root of that number. Square root of 16 is 4. Don't divide by 2. Take the square root. So my center is a positive 2 and a negative 4, and my radius is a 4. And then, okay, I go graph it. By the way, a fail-safe is look at the size of your graph. If you were to do 16 squared, you'd get 256. Can you make 256 boxes? No. So you would hopefully snap to, oh, wait, I went the wrong direction. Okay, make sure you take the square root. So we're going to go 2 over and down 4. 1, 2, 3, 4. I'm really sorry these graphs are so faded. I need to change them. So 2, negative 4 is here, and then my radius is 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And this just helps me being able to line up my compass. So line up your compass, find the circle. There we go. And there you go. Your circle, neat, clean, pretty, and efficient. So you will do the other 4 of these on your own, but we're going to go to the back. Okay. So, oh, we did number 4. You have 4 at the top to do on your own. You have 4 here to do on your own. So then we're going to flip it over. Okay. Now back here, it's actually pretty much the same as this bottom part on the front. So which one would you like me to do? Because we are going to identify the center and the radius, and then we're going to sketch the graph. But really we mean compass, right? So you're going to identify the center, that's 1 point. You're going to identify the radius, that is 1 point. And then you're going to graph it. That is 1 point. So each question is 3, right? And just like on the front. So I need somebody in the room to pick one of these. 6. Okay, let's go do number 6. That's right. If it's positive on the inside, then H is a -1. If it's +2 on the inside, then K is a -2. This 25 is R squared. So I need the square root of that. 5. Very nice. So I'm over here. I'm going to write C for center, and then I'm just going to put down -1, -2. There's my center. That's worth 1 point. My radius is a 5. That's another point. And then I'm going to go graph it, and that's another point. So to the left 1 and down 2, put my center. How big is my radius? 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 here and 5 there. Okay. And then compass. Put your compass on the center, and then you go find one that is the closest that you can. And then you draw your circle. Ta-da! There it is. Nice, neat, clean circle. So your job then are these 5. You have 5 on the back to do. Okay?